Hello, in this video we will be synthesizing a ferrimagnetic compound of iron called magnetite. It's perfect to just play around with, and in specialized conditions it can be used to make a ferrofluid. Warning: sodium hydroxide is corrosive and ferrous chloride is toxic. We start off with a solution of ferrous chloride, also known as iron 2 chloride, which was prepared by dissolving iron in dilute hydrochloric acid. The iron took about 4 days to make a decently concentrated solution in the acid. So we first take 2 drops of this solution and combine it with hydrogen peroxide to produce a deep red, almost black solution of ferric chloride. 2 drops of the solution of ferrous chloride are added to the test tube. This is followed by the addition of hydrogen peroxide until it turns completely red. The bubbles are due to the decomposition of hydrogen peroxide. Allow the solution to stand for some time to make sure that everything has reacted. A few seconds will be enough. What is happening here is ferrous chloride reacts with hydrogen peroxide and hydrochloric acid to form the ferric chloride and water. This is followed by the addition of 2 milliliters of water into the test tube to dilute it. We then add a single drop of ferrous chloride to the solution. We do this because for the reaction to work, we need both ferrous and ferric ions in the same solution. We have to take the test tube now and add dilute sodium hydroxide until both a red and then a green precipitate appear. So keep adding it in and constantly shaking it, and our precipitates will appear. You may observe that the solution is heating up due to the reaction of sodium hydroxide with excess hydrochloric acid. So add an excess of sodium hydroxide, shake it and let it stand for some time. What is happening here is, when the pH is raised to about 3 or 4, ferric chloride reacts with sodium hydroxide, forming sodium chloride and a red precipitate of ferric hydroxide. When the pH rises to about 9 or 10, ferrous chloride reacts with sodium hydroxide, forming sodium chloride and ferrous hydroxide, which is a green precipitate. Then, if you allow the solution to stand for about an hour, ferrous hydroxide will combine with ferric hydroxide to give our product magnetite and 4 moles of water. I have allowed the product to settle for some time, and when a strong neodymium magnet is brought near it, you can see it climbs up the sides of the tube. The effect is very weak in the test tube, but I can show it much better in one of my previous runs. This vial contains the same thing, magnetite, but this has been allowed to settle completely and it's reacted for a long time. So when I pull the magnet, you can see how nicely it rises up the sides. The product is very strongly attracted to a magnet but does not get magnetized. Time to have some fun with it. A dropper is taken and a few drops of the suspension are placed onto a glass slide. Then we bring the neodymium magnet underneath it, and as you can see, it moves along with the magnet wherever you take it. So, in summary, we have synthesized a magnetic compound of iron using ferrous chloride, hydrogen peroxide and sodium hydroxide. Thank you for watching.